Hello everybody. Today we are going to talk about how to build, deploy and scale your Django one single page applications using GraphQL endpoints. So before I begin, let me tell a little bit about myself. I am dhilipsiva. I am an optimistic nihilist, democratic socialist, and I code for fun and profit. I love science, Python, FOSS and Tamil, which is my mother tongue. I'm a dad of two, an environmentalist, storyteller and a gamer. I'm a jack of all trades but master of none, and I volunteer for a lot of progressive movements around the globe. So before we begin, a standard disclaimer: I have no idea what we are talking about. I play around with a lot of things: front and back end mobile applications, IoT. As long as it's coding, I love to experiment with different things, which is why I'm a jack of all trades, and I end up having a lot of breadth about a lot of things, but not enough not enough depth. So about my credentials, have about 11 plus years of experience in Python. I built over 20 different products using just Django alone. I've scaled more than 5 products to serve more than 5 to serve nearly millions of requests per second. I built a device farm, iOS and Android device farm, which was used for security testings, and I was involved in building a Bitcoin mining farm with Raspberry Pi and custom ASIC chips. It is sort of like an AWS for Bitcoin miners, if you will. And as for my profession, I work as a VP of Engineering at Reconsys, and I work as a Hitoshi Kage at a non-profit called Timis. So let's get this question out of the way. Why GraphQL? It's much more standardized than the fragmented RESTful implementations. Everybody have their own flavor of RESTful implementations, and it's all about their own preferences. But that the same thing cannot be done in GraphQL. GraphQL has this very specific stretch of format that you'll need to follow. In GraphQL, you get a live and browsable documentation out of the box. There is no need for you to maintain a different API documentation like you would do with Swagger or any other thing which is used for REST. There is no back and forth communication between the API developer and the React developer. So usually every GraphQL endpoints give a GraphQL Explorer where you are free to sort of like explore all the queries and mutations and subscriptions and types and whatnot. And you can write very precise queries. In RESTful framework, it doesn't matter if you just need like 2 fields, or if you need a bunch of fields, or if you need like less nested levels of fields. It'll always return you the same response, but that's not the case with the with GraphQL. You can write like very precise queries. You can request for what you want. If you want n degree of nested response, you are free to do that, assuming GraphQL allows you to do such queries. So let's take a look at a very buggy demo application, which I call the StackOverflow. It's a very silly clone of StackOverflow. So let's go and register ourselves a user. For now, I'm just going to call them test user, which is the username, and test user, which is the password. Let me register. Okay, it says now it is successfully registered, and I'm going to log in as the test user. So as you can see, there are no questions on our system at the moment. So let's go ahead and add a question. How to do join operations in Python? How to join an array of texts in Python? Fine. So this is a sample question that we want to ask. As you can see, as soon as the question is added, it says there are 0 upvotes, 0 downvotes, and there are no answers. So let's go ahead and add a new answer. Let this answer be foo bar, and then we just simply join. We just simply do a space dot join of 1 bar. This is going to do a join operation on array. So let's submit that answer. So here's the first answer, right? So the first answer which is given by me, the same test user, is join foo and foo. You can add comments. So if you see there are no comments here, I'm going to add a new comment saying thank you, submit, and then there is the comment. Fine. And you can upvote on a comment, or you can downvote on a question. Fine. So that is it. So that is our entire application. Now that we know what our application is all about, let's dive into the tech stack that we've used here. So it is on the backend, it's built with Python Django. I've used this library called the Graphene library, which is used for GraphQL implementations. And there is Django GraphQL JWT. It is sort of like it's a plugin for Graphene library, if you will, where you can have JWT token based authentication. And we have used Django rules. I just put the Django rules as a hint here, as sort of like a recommendation that you could use, that upper object library, upper object permission library that you could go for. And I've used the Postgres database. On the front end, it's JavaScript with React, and I've used Relay, and I've used ECPC state management library. So Graphenes have custom fields. The code is synchronous. You can only write synchronous code with Graphene. It's more mature. It is the status quo, and it has a fantastic integration with Django. On the other hand, using Strawberry Rocks, the schema definition is completely based on data classes. It's asynchronous, uses async.io. It's not so mature. It's being a relatively new library and all. Maybe it is the future because it looks really nice. But at the moment it has a very minimal Django integration, so it made sense to go with the Graphene. Let's take a look at per object permissions, or row level permissions, if you will. So choose a rule based framework rather than choosing a database based framework. A rule based framework like Django rules would not hit your database for checking if a user has permissions or not, because it's completely based on rules and you can just represent within Python code. But in libraries like Guardian, you will have to set these permissions on the database. So for each permission check you made, it makes a database call. So which means Django, when you're using Django rules, there are less DB calls, which means less latency. There's no unnecessary migration due to change in logic. So permissions, right, they change every now and then. You come up with a team strategy, and then you decide maybe that's not the right thing to do, and then you want to change it to something else, or you add new roles. So when you do things like this, right, you'll have to go back and add migrations, because all your permissions are relying on your database now. So which is something that you can totally sidestep if you're using a library like Django rules, and it's easier to maintain compared to frameworks that depend on DB to apply permissions. So let's take a look at our project layout. So this is my backend repository, and as you can see, I have a StackOverflow root app here. So basically the StackOverflow OpenFlow is where is the one that has your settings.py and wsj.py. So if you've read books like 2 Scoop of Django, they recommend you to keep configurations in a separate folder like config, which is not something that I like. It's just a matter of a personal preference. Is that I like my things being namespaced. All the settings you would not access namespace to access it, you will just import it from django.conf. So I'm just saying it's nice to have everything within under the same namespace, and that's sort of like the base layout that we've been following here at Reconsys for all our projects. So that is that. And inside StackOverflow we have apps like Contrib, Core, and Q&A. Say StackOverflow GraphQL. As you can see, everything is namespaced in the StackOverflow, which is something that I like. And then typically, right, when you create a Django app, you would find admin.py, apps.py, models.py, test.py, and views.py, and everybody knows what these files does, or else I have no clue what you're doing at DjangoCon. But in our modules, we have these files. There is admin apps, which is by default that's there, and then behaviors is where you keep your behavioral logic like commentable or votable, things that you're able to do as a user, right? So that's where it goes into behaviors.py. And then choices.py is basically where you keep all your database choices. Inputs.py is like forms.py. When you want to get a bunch of input from the client side, that's where you put your definitions at. And everybody knows what models.py is. And then mutations.py, so if you notice, there is no views.py. So instead of views.py, there is two more files now, which is mutations.py and queries.py. So the mutations.py, as the name says, it has all the mutations, and queries have all the queries. And then we have types. Types is sort of like your serializers, right? It contains all the definition, all the payload definition that GraphQL responds back to the user with. So let's walk through the source code. First, I would like to walk you guys through the backend code, right? So let's open core.py, and in the core.py, let's go through some of the files. So basically, we have this choices.py. This choices.py is nothing but all the choices, all the database choices that the models have. So for example, there could be an admin type of user or a client type of user. There might be different types of uploads. You can upload a profile picture, or you can upload an Excel report, or something like that, right? And then I have an upload status. I have an upload status which says what's the upload status. So basically, this choices.py file has all the DB choices. And in the models file, you can see there is a base model. So basically, we use UUID as the primary key, and then the user has a user kind, and then there is an upload object. There is an upload model which is used for tracking all the uploads that are done to the system. We have our inputs.py, right, which is more like forms.py. It will have it will say what are all the inputs that the GraphQL expects. So for instance, the register input, right? So at the time of register, we only require username and password. So if you were to look for the register input, you would find that there is username and password. Feel free to ignore the client ID mutation, which is nothing but a relay, which is nothing but a property that's added by relay. So you can safely ignore it. And then we have types.py. So every model typically will have a type.file associated with it. It's like Django serializes. It's like Django model serializes, if you will. So here is, for example, the upload, right? The upload in this place, it can have a pre-signed post URL. Generally speaking, what people will do is that they'll upload from their browser to their server, and then server uploads to S3 and then returns that response back to the browser. So let me tell you why that is very problematic. Say you just have two servers, right? And there are hundreds of people trying to upload huge files, and that's going to be a problem because everybody is going to be uploading to the same file. And let's say you also have to redeploy your code during this time. It's not easier to do that because there is active uploads that are going on. So that is something that we should actively try to avoid. The indirect upload to S3 through the servers, we should try to avoid it. So what I usually do is I create a pre-signed URL. I let the browser upload the file directly to S3, and once it's finished uploading, it will make a mutation call. So let me just walk you guys through the mutations here. So this is the mutations files here. So as you can see, there is a register mutation, which means it's the mutation that sort of like registers new user. I create new user objects here, as you can see, and then there is a create upload and finish upload. So the function of this create upload and finish upload is that when you say create upload, it will create a new upload object, and it will respond back to the user with an upload object. And what we do is, when we are getting this upload object, since the return type of upload object is is an upload type. The upload type, if you look at the upload type will automatically have a pre-signed URL. So when it resolves, it's going to generate a pre-signed post URL and it is going to return it to the user. So when we get a pre-signed post URL on the browser, we are going to upload it directly to the S3, and then we make another call saying, so once it's finished uploading to S3, we make a call saying finished upload mutation. So in this finished upload mutation, we are just going to send the ID of the upload, and it will immediately set it to uploaded. And then it will just end, and then if there are any so this at the moment is not a valid task, it's not actually there, it's there just for demo purposes. So if you want to do some post processing, right, so for example, you uploaded a file object and you uploaded a profile picture and you want to optimize the size of it using ImageMagick or something, that is something that you could do within within tasks like this. So that is all your mutations. And then we have all our queries. So queries are nothing but all the fetch calls. So that's where you fetch your data from, and mutations is when you alter something in your database. So that's the difference between queries and mutations basically. So we have like me query, which means it will return the currently logged in users input. We have the uploads query, and we have the relevant resolve methods for each of these things. So these are sort of like additional files that we'll be creating when we are using Graphene. But this core app is a bit special. It has even more additional things. As you can see, it has decorators.py, which is basically, it has all the login required decorators, the client required decorators and so on. Whatever decorators you need, you can just keep it over here. Say for instance, I'm going to query all the content types in the system. And this content types will have an ID, label, app label, and model. So when I run this, I get a bunch of responses back. And then we have a storage.py. The storage.py is nothing but it just has a bunch of helper functions to sort of like upload files directly to S3 from browser, and then generate pre-signed URL keys and so on, right? So it has all the helper functions to interact with S3 basically. So that is it. So this is all the files that are in the core. So let's look at all the files that are in the Q&A. Q&A is nothing but it represents all the questions and answers that are used in the system, question, answers, votes, and comments. So let's have a look at model, right? So basically we have things like vote, comment, questions, and answer. The vote, as you can see, it's a generic foreign key because you can apply vote to any object like answer, question, or comment. You can use the same table for all the three entities. So that's why it has that is why it has a generic foreign key. And the way that you refer it from your comment, from your referred object, is that you use a generic relation. So as you can see here, we have used a generic relation, and we've said votes is basically a generic relation to vote. Fine. And then we have questions, which is basically what questions, and then we have our answer entity, which stores all the answers. And as you can notice, all the models have custom managers. Fine. Which is defined in behaviors.py. So if in behavior, if you were to look, we have a bunch of things like votable query set, which is any object that the user can vote on can exhibit a votable behavior. So it has a votable query set. It can have an upward count, downward count, and a total vote count. And then we have a commentable query set, which means these are the models on which the users can comment on. So that is it. And then we have a vote count, right, which is nothing but a case when statement to count the number of upvotes and downvotes. So this vote count is nothing but just a complex query which will count the number of either the given vote kind, which is either here, as you can see, it's either upvote or downvote. It will collect all the number of votes it has, and and then finally the total vote is going to be the number of upvotes minus the number of downvotes. So as simple as that. So that is it. And if you were to look at the queries.py, this queries.py is now going to you know so since you use query set as managers, you get to do things like this with vote count and with comment count, right? So this thing will annotate your query set with relevant data, so that it can be picked off on the client end as well. I've seen many people struggling to represent generic foreign keys in REST or API calls. A neat little trick to take care of it, which is like resolve comment. So this resolve comments basically will take an object ID and the content type ID, and it'll get all the comments for that specific object ID and content type ID. So how do we define this content type ID? If you were to look at the core queries, all the content type are listed here. So let's just play around with the GraphQL Explorer for a little bit before moving on. So as you can see, all the queries and mutations that we defined in those files are here. Every queries and mutations that you defined are here. And let's try to make a sample query, right? So this you can forget. So we are going to get all the content types first. So when you run this, as you can see, it gets all the content type. So it gives like a really nice documentation that you can explore around with, and you can also play live with whatever data that you have on your local. So this is a really handy tool to have. So we also have history here on this history button. If you just click on the history, it will show all the past 20 or so queries and mutations that you have done. So let's look at this input mutation, right? So this is a login mutation. So for example, I'm just giving a username and password, which is hard coded here, and I'm just going to run it. And as soon as I run this mutation, I get a token back. And any further calls to the views that are protected by login required, we send them with JWT tokens, with these JWT tokens. So that is all about the client side. That is all about the Django server. Let's take a look at the front end app, which is StackOverflow app on my local. This is where I have it. So I'm already inside the source folder. I'm not going to worry about the things that are outside the source folder. We are only interested in things within the source folder. So as you can see, I have a command here. So let me just show you guys that command. So I have app export. Fine. I have this management command called app export. So when I run it, it's going to export the choices.js and the schema.json from our repo to the React repo. And in the React repo, you get to see what are all the choices. So every choice that you declared in choices.py is now available in your choices.js. So when it is exported like this, you can do things like routes, questions, vote. So this is a vote component, right? So this basically has a vote button. It has a upvote button and downvote button. So basically what I can do is that I can import these choices. Fine. And I can just say choices.votekind.down or choices.votekind.up. Okay. And then let's now have a look at the non-production deployment, which is using Vega. Again, the source code is located right over here. I've forked it. Let me just open DjangoCon Vega. Or should DjangoCon 2021 Vega. Okay, so I hope the font is visible. So this is nothing but this is nothing but a generic Docker Compose boilerplate. So if you were to open this Docker Compose, so So Biga is nothing but just a generic Docker Compose boilerplate, which we use to deploy, for non production workloads. The reason that we use Docker Compose is that we don't want most of the clients that we have, they don't have huge or deep pockets. Most of the times, they spend money out of their own pockets to sort of build their own product. They have not even raised funding, so we don't want to put a lot of bill for them. I mean, we don't want them to get a lot of bill from AWS, right? So what we do is just we take a $5 server, we create a $5 server through Docker machine, and we deploy it using Docker Compose. So this is like a sample configuration of the Docker Compose, right? This is not the actual thing, like we don't use these services and all, so it's just here for a reference reason. But as you can see, there is going to be a worker instance, which will build your backend folder, and then we have the configurations to run beat and backend from your worker service. Here we use this thing called traffic, which is a reverse proxy. The advantage of using traffic is that when you're using it within Docker Compose, you can just say where the sock is, where the docker.sock file is. So once you mount it onto the traffic, it will automatically load balance within your containers. It will automatically reroute all the traffic. You don't have to do much of any configurations to like you would do with Nginx, because this is cloud native. It is supported by the CNCF Foundation. If you guys have not already checked it out, you should really check it out. So this is a project that's worth checking out. So all the documentation is it's clearly it's written step by step over here. If you guys have any doubt, be sure to write me an email. I'll be sure to respond to you guys. And then AWS Copilot. This Copilot is an interesting utility, right? And then we have AWS Copilot for all the production deployment. So AWS Copilot is basically a helper CLI tool, which will help deploy your applications on ECS, on AWS Fargate. So AWS Fargate is basically a serverless containers. It's very reliable, and it's very easy to scale because it has like all the scaling configurations built in. You just have to specify the threshold for your CPU and your memory in your manifest files. Once you do that, as soon as your your resource usage meets one of these as soon as your resource usage crosses one of these thresholds, it will automatically scale your containers. So it's like very straightforward. So it's always, software engineering is always about trade-offs, right? So for being vendor dependent, you gain a lot in terms of scalability and reliability. And this is very useful for teams like us, because I've always exclusively worked with small teams, which usually doesn't go more than 10 people. And where we don't have a lot of specialized roles, so this is like really handy for people like us. And it's cheaper than Lambda serverless functions, because it's not only cheaper, it also has low latency compared to Lambda functions. And as far as this single page application deployments are concerned, don't let your server handle static files. It's an unwanted load on your server. It's going to introduce some latency, and it might not be that reliable. The way to do it is just build your single page application, push it onto S3, have it proxy through a CloudFront CDN, and then attach a ACM certificate to your CloudFront CDN if you have a custom domain, which will give you free SSL certificates. So this way it's much cheaper than alternatives like Netlify, and it has less latency compared to when you're trying to serve from your own servers. And then there are different ways to go about it. If you want an automated deployment, again this comes from the same Biga repo, DjangoCon EU 2021. So if you were to visit the Biga repo, we have a S3 front-end deployment script here. which is like manual thing, and I have a PyInvoke task. So this is my PyInvoke task for setting up ACM, S3 and CloudFront. And this is the same thing, only this is done manually. There are about some 54 steps. So that's it, folks. So I guess that is all there is to talk about. So my handle is dhilipsiva on both Twitter and link on GitHub. You can reach me using the handle, or if you want to mail to me, it's dhilipsiva@pm.me. Or if you want to text me, I'm also available as dhilipsiva on Telegram. Thank you so much for your time, guys.